Hello, welcome again. We are solving some questions of production engineering or manufacturing science. The topic is metal forming. Question number 9 is calculate the punch size in mm for a circular blanking operation for which details are given below. Size of blank 25 mm, thickness of sheet 2 mm, radial clearance between punch and die 0.06 mm, die allowance 0.05 mm. Option A 24.83, option B 24.89, option C 25.01 and option D 25.17. So in blanking the punch size, in blanking the size of die is same as that of blank. So size of die is your 25 and size of punch is size of die minus clearance minus 2 into clearance minus the die allowance. So that is 25 minus 0.06 into 2 minus 0.05, that is 25.83. So answer is option A. Next, question number 10. The shear strength of a sheet metal is 300 MPa. The blanking force required to produce a blank of 100 mm diameter and from a 1.5 mm thick sheet is close to option A 45 kilonewton, option B 70 kilonewton, option C 141 kilonewton and option D 3500 kilonewton. So the shear strength of the metal is 300 MPa, and when we shear a when we when we apply a punching force on a blank, then the shear area for the blank is your pi dt. So pi into d is your diameter and t is thickness. So the load will be shear strength into area, that will be 141,371 Newton or 141.371 Newton kilonewton. So answer is option C. Next, question number 11. Answer is 141.371, option C. Okay. Next, question number 11. The force requirement in blanking operation of low carbon steel sheet is 5 kilonewton. The thickness of the sheet is T and the diameter of the blank part is D. For the same work material, if the thickness of the blanked part is increased to 1.5 D, the thickness is reduced to 0.4 T. The new blanking force in kilonewton is option A 3, option B 4.5, option C 5, option D 8. So here as the material is same for both the blank, so shear stress will be same. So, okay, so let tau be the shear strength and then the force required is tau into pi dt. So tau here 5 and if you divided by pi dt, shear force is your 5. In the first case the force is 5 kilonewton and if you divided by pi dt, then it will be shear stress. For the second force, for the second part, let P be the force and diameter is now 1.5 D and thickness is 0.4 T. So now from 1 and 2 we have 5 by pi dt and P by pi into 1.5 into 0.4 dt. So dt will cancel out, pi will cancel out, so P will be your 3 kilonewton. So answer is your option A. Next, question number 12. A metal disc of 20 mm diameter is to be punched from a sheet of 2 mm thickness. The punch and die clearance is 3%. The required punch diameter is option A 19.88 mm, option B 19.94 mm, option C 20.06 mm and option D 20.12 mm. So diameter of blank is 20 mm and diameter of punch is diameter of blank minus 2c. So as the clearance is 3% of 3% of 3% means 3% of thickness. Okay, so thickness is 2, so it is so diameter punch comes out as 19.8 mm. because in blanking the size of die is same as that of uh, blank. Okay, now we have to blank a punch. We have to uh, blank a disc of diameter 20 mm, so the diameter of die will be 20 mm. So answer is option A. Next, question number 13. In a blanking operation, the clearance is provided on option A die, option B both on die and punch equally, option C punch, option D neither punch nor on die. In blanking, the die size remains same and the clearance is provided on punch. So answer is punch. Remember B. B means blanking, D means die. In blanking, die size remains same. Okay, and remember HP. H means hole and P means punch. In hole making process, the punch size remains same. Okay, that is the two things that you have to remember. One is BD, other is HP. In blanking, die size is same. In punching, hole size is same, and clearance is provided on other things. Okay. Next, question number 14. The cutting force in punching and blanking operation mainly depends on option A, the modulus of elasticity of metal, option B, shear strength of metal, option C, bulk modulus of metal, option D, the yield strength of metal. So it depends upon the shear strength of the metal. So answer is 14. Answer to 14 is option B. Good. Next, question number 15. A 50 mm diameter disc is to be punched out from a carbon steel sheet 1 mm thick. Diameter of the punch should be option A 49.925, option B 50.00 mm, option C 50.075 mm. So here answer can be none of these, and answer can be 49.925 also, because in blanking the diameter of the diameter of the die remains same, that is 50 mm, and clearly provided on punch. So answer can be A also, or answer, because no particular clearance is given, so answer can be B also. So we will write here A or D. Okay. So we'll write here answer can be answer can be A also, because clearance is provided on punch. Okay. Next, question number 16. A shell of metal, a shell of 100 mm diameter and 100 mm height with a corner radius of 0.4 mm is to be produced by cup drying. The required blank diameter is option A 118 mm, option B 161 mm, option C 224 mm, option D 312 mm. So here the diameter of blank is given by root d square plus 4dx. D is the diameter of the cup, diameter of the shell, and h is height of the shell. Okay, and D is corner radius.